Welcome to EDU World Space.
Okay, so we have a hollow sphere, okay, with inner radius A, outer radius B, okay, as it shows the diagram. And we know the volume charge density, okay, it's the function given here by rho. And we want to find the magnitude of the field E, okay, the electric field, when we are like in this, in a point here, okay, that is greater than A and smaller than B. Okay, so any point in the isolating thing. And how do we do this? Okay, so first, notice that we do have the volume charge density. Okay, we also know that dV, okay, equals we know the volume of the sphere. So if we take the derivative, we can find that this is 4 pi r squared, and this is the radius of the sphere. Okay, dr. Okay, in terms, so we have like the differential of the volume in terms of the differential of the radio. That's just derivating the function of the volume. Okay, you can do it, and this is actually the area, no? But we'll talk about it later. Okay, and we know that the charge, okay, will be equal for the integral, okay, from A to R of the density, okay, the charge density, uh, times dV, the differential of the volume, okay? And you can actually see we have these two values, okay? Now I use here R prime, okay, because I'm calling R the point at which I am here, okay? So R prime is just the R I am coming through here, okay? So when you substitute the values, okay, from A to R, okay, we substitute the charge density is alpha divided by R, okay, times the differential of the volume, that is this value, 4 pi r squared dr, okay. I can eliminate one r, and then I find that this is the integral of from A to R, okay. I can leave the constants out of the integral, okay, and so this is alpha 4 pi, okay, and I have the r, okay, r prime, okay, this will be r prime, so, sorry, okay, and if you make this integral, it's easily to find that this is 4 pi, okay, alpha 1/2, and this is the value of the integral, okay, of r squared minus a squared. Okay, you can eliminate with this. Sorry, this is 2 pi alpha. Okay, r squared minus a squared. Okay, I already valued the integral here. And now Gauss' law states that E times the area, the electric field times the area, is equal to the charge enclosed, okay, divided by epsilon 0. So we already found the charge, okay, and we have the area. Remember, this is also the area. The differential of the volume is the area. So the area is 4 pi r squared, okay, and I substitute everything here to because I want to find terms of E. So I find E times 4 pi r squared is equal to the charge enclosed, that is 2 pi alpha r squared minus r squared divided by epsilon 0, okay? And so when you rearrange for E, then you find that E equals, okay, alpha divided by 2 epsilon 0 times 1 minus r squared divided by r squared. Okay, so this is the value of the electric field. Now, we want to find if we point a charge here in the center of the sphere, we want to know the value and sign of this charge for the electric field. It's to be constant. Okay, so I already know that this is the electric field. Okay, but so I know that EQ, okay, or the electric field due to a point charge is the charge, the value of the charge divided by 4 pi epsilon 0 r squared. Okay, and this is the distance from the charge. Okay, so the total electric field, it's going to be the electric field I had originally. Okay, that is alpha to epsilon 0 times 1 minus I squared divided by r squared, okay, plus the electric field of the charge, that is Q divided by 4 pi epsilon 0 r squared, okay? And, okay, I have to, how do I know that the field is constant? Then I have to take its derivative with distance, okay? When this is equal to 0, I know the field is not changing, so it is constant, okay? And when you do this from this function, you will find that this is a squared, this is a minus sign to epsilon 0, d over dr on the square. See, I just separated these terms, okay, this and this, okay, and this is plus q divided by 4 pi epsilon, okay, times sorry, I just put out the constants, and d divided by dr of let me just move this up one over r squared, okay. So you see, this first, when I derivate, this first one goes to 0, okay, because I have no r there. This is this first term, and this one, I'm going to call it the first term, and this is the second term, okay? And I did this like this. I didn't derivate because you can see that actually the derivatives are equal. And since I have this equal to 0, I can just cancel this. And then I find that for this to be constant, okay, I have that minus alpha a squared. It's I only have left these constants, okay, divided by 2 epsilon 0 plus q divided by 4 pi epsilon 0 is equal to 0. Okay, so you can see this cancels each other out. This limited to this is a 2. Okay, and when I solve for q, I find that q is equal to alpha a squared 2 pi. Okay, and if you actually want to find this is the answer, and if you just happen to find the value, want to find the value of the total electric field, you just substitute this and it is, okay? But this is the answers.